Golden Iris Productions presents Deriving Equivalent Equations for the Gravitational Constant G by Mark F. Dennis. Revealing Hidden Structures in the Foundations of Physics. In this presentation, we will explore two equivalent expressions for the gravitational constant G. Using standard relationships from Planck units and electromagnetism, we will show that these equations are mathematically identical and examine the implications of that result. Overview. We analyze two expressions for the gravitational constant. The first is G1 equal to Planck length squared times c cubed divided by h bar. The second is G2 equal to 4 pi times Planck length squared times the fine structure constant divided by epsilon naught times mu naught squared times q squared. Our goal is to show that these two expressions are mathematically identical. To do this, we use only the definition of the Planck length, Maxwell relations, the definition of the fine structure constant, and CODATA 2022 constants from NIST. Planck length definition. The Planck length is defined as the square root of h bar times g divided by c cubed. Squaring both sides gives Planck length squared equals h bar g divided by c cubed. Solving for g gives g equals Planck length squared times c cubed divided by h bar. This exactly matches expression G1. No additional assumptions are required beyond the definition of the Planck length itself. Electromagnetic expression for gravity. We now consider the proposed electromagnetic form for gravity. G2 equals 4 pi times Planck length squared times alpha divided by epsilon naught times mu naught squared times q squared. Our objective is to reduce this expression using standard electromagnetic identities.
Step 1. Maxwell identity for light speed. From Maxwell's equations, the speed of light is equal to 1 divided by the square root of epsilon naught times mu naught. Therefore, c squared equals 1 over epsilon naught mu naught, and c to the fourth power equals 1 over epsilon naught squared mu naught squared. This relationship will be used in the next steps of the derivation. Step 2. Fine structure constant. The fine structure constant is defined as q squared divided by 4 pi epsilon naught h bar c. Rearranging this equation gives q squared equal to 4 pi epsilon naught h bar c times alpha. This expression for q squared will now be substituted into G2. Step 3. Substitute into G2. Starting with G2, we substitute the expression for q squared. This gives 4 pi times Planck length squared times alpha divided by epsilon naught squared mu naught squared multiplied by q squared. Q squared is equal to 4 pi epsilon naught h bar c alpha. The factors 4 pi and alpha cancel. The result is Planck length squared divided by epsilon naught squared mu naught squared h bar c. Step 3 continued. Simplify. Using the Maxwell identity that c to the fourth power equals 1 over epsilon naught squared mu naught squared, we substitute directly into the equation. This gives Planck length squared times c to the fourth divided by h bar c. Simplifying yields Planck length squared times c cubed divided by h bar. Therefore, G2 is equal to G1.
Dimensional analysis. Next, we verify that the units are correct. Planck length squared has units of meter squared. C cubed has units of meters cubed per second cubed. H bar has units of kilogram meter squared per second. Combining these units gives meters cubed divided by kilogram second squared. This is the correct SI dimension for the gravitational constant G. Numerical verification. We now evaluate the expression G equals Planck length squared times c cubed divided by h bar. Using CODATA 2022 values, the Planck length is 1.616255 times 10 to the minus 35 meters. The speed of light is 2.99792458 times 10 to the 8 meters per second. And ℓ is 1.054571817 times 10 to the minus 34 joule seconds. The resulting value is extremely close to the observed gravitational constant. The observed value of G is 6.67430 times 10 to the minus 11 cubic meters per kilogram second squared. This agrees with the accepted CODATA 2022 value reported by NIST. Interpretation and implications. We have shown that G2 is equal to G1 using only Maxwell identities and the definition of the fine structure constant. As a result, the gravitational constant can be expressed either in terms of Planck length, the speed of light, and ℓ, or in terms of Planck length, the fine structure constant, vacuum permittivity, vacuum permeability, and electric charge. In this formulation, gravity appears as a derived constant composed of electromagnetic vacuum parameters. This result supports models in which gravity emerges from electromagnetic properties of the vacuum and manifests through a time gradient rather as a fundamental force.
Thank you for watching. If you enjoyed this presentation, please take a moment to like, subscribe, and share this video with others who are interested in physics, cosmology, and the deeper foundations of reality. For more content, visit my two YouTube channels, Mark F. Dennis at Golden Iris Knowledge Quest, where we explore physics, cosmology, science, and emerging ideas about the structure of the universe, and Mark F. Dennis at Golden Iris Religion Quest, where we examine religion, spirituality, biblical studies, Jewish mysticism, and the history of religious thought. Your support helps these channels continue to grow and allows me to create more presentations, books, and educational content. Thank you again for watching, and I look forward to seeing you in the next video.